Hello, everyone. This is the homework solutions for the first week of Math 1020, Section 113. Russell Chamberlain talking at you. Alrighty, I thought I would just run through some examples of how to solve these problems. So we'll get right into it. So the first problem we had was, change pen color. This is the first solution video I've done. Well, it's the second one because I made a mistake on the first one. So hopefully this one will work just fine. So homework one from the first day of class. So this was the assigned 116 homework. And it was algebra aerobics, which I'm going to abbreviate AA 1.1. Sometimes there's an A or a B. I noticed that some people did 1.2a algebra aerobics instead of 1.2b algebra aerobics. It's fine for now. We'll figure it out here in a little bit. We'll talk about it Monday. So we had number one of that. Yeah, we had number one of that. All right, and this was just kind of checking to see, you might have translated decimal percent to fraction and back and forth a lot in your life, but it might have been a while. So I thought maybe we could do a couple of these and remind ourselves how to do it, and then we wouldn't have to talk about it much the rest of the semester. That is not to say these questions are prohibited in class or anything. Ask whatever you need to ask. All right, so if you look at the good PDF that I posted later after I posted that crappy HTML version of the textbook, the first fraction in Algebra Aerobics 1.1 is 7/12. And the way to do this is to put it in your calculator. There's no way around it. I mean, long division, but who wants to do that? Calculator. And you get a decimal answer, 1.5833, and the threes go on for a while. I just stopped at 4 decimal places. Okay, so here is my fraction. Fraction. Here's my decimal. So then I want to move to a percent. And to do that, I take this number here, 0.533, and I multiply by 100. So if you're going to do it in your calculator, just type that in, multiply by 100. Done. Or if maybe you're a little more comfortable doing this stuff without a calculator, you might recall that multiplying by 100 is the same thing as moving this decimal 2 places over. And so we come out with 58.33%. All right, so from there, in that case, we moved from fraction, then we went to decimal, and from decimal, we went to percent. So now I'm going to go percent decimal to fraction. And then if you're given a decimal one, just, well, you can go right or left from there. Sort of, yeah. Okay, so change my color back. All right. Okay, so I'll take the 2% one. So say you're given 2%, right? Well, to back that out into a decimal, divide by 100, right? So this gets us to, so this is percent. And this gets us to a decimal where we divide by 100, or we move the decimal to the right 2 places, right? So here's a decimal. I'm going to go add a 0, drop my decimal down there. And so over here in the decimal world, I write this as 0.02. So this is the decimal version. So to get to the fraction version, Well, I have to ask myself. It's kind of like I look over here and I say, well, here's the tens place, that's the hundreds place. So how many hundredths do I have? I have two of them. Well, 2 out of 100 simplifies to 1 out of 50, right? So there you go. You start with a fraction, you translate it into a decimal, you get a percent. You start with a percent, translate it into a decimal, get a fraction. If you're given a percent, percents are always out of 100. So yet another way to do this would be to say to yourself, well, that's 0.2%. Well, that's 2 hundredths. And we just skipped this whole middle step here, this whole getting the decimal first step. We just went straight from percent to calling that 2 out of 100, which is what percent is. All right, so that's problem one. I'll get us another page. And so the next one is exercises. I'll abbreviate EX for 1.1, so section 1, chapter 1. And we're doing number 9. I might also write these as EX 1.1.9 sometimes. Okay, so this one has to do with a company that has 30 people who are paid $18,000 a year, 8 people that are paid $36,000 a year, and 2 people that are paid $80,000 a year. Okay. And the question is, what's the average? Well, in this case, this is the case where it's really effective to use the weighted average technique we saw the other day. So my total employees, are 40, right? So that's our N. When we talk about N as the number of things we're taking the average of. Okay, so 30 out of the 40 employees make 18,000. Now note that I'm dropping the dollar signs. We'll have to add them back in at the end to make this problem meaningful, but for the moment I think it'll clog my page. Plus an 8 out of the 40 people make 36 grand. And then 2 out of the 40 people make $80,000 a year. And so, yeah, we get those 3 decimals, multiply them by the appropriate numbers here, add it all up, and you get an average of $24,700 a year. So a little bit higher than the big block of employees over here that you have making 18,000, not as much as the small block making 36,000. So what that tells you is that these 2 blocks together of employees have, I'm doing air quotes and you can't see them, but have pushed the average upward, you could say. So what is the median? Well, there's a simple way to do this. And the way I think about it is like, here's all our things. Here's a big bucket with all our numbers in it, right? Well, think about this as a list, I guess, of all the numbers listed out, like we're about to take the median. Well, you notice the first 3/4 of them are 18s, right? 18,000s. And then from there, all but 2 of them are 36,000s, right? But all we care about, right, is the 20th number. And actually, we care about the 20th and 21st numbers, right? This is an even number of things, so there's nothing in the exact middle. We would take the average of these 2 numbers, which have to both be 18s, right? Because all the way up to the 30th entry are 18s. So we'll take the average of 18,000 and 18,000. And it hardly seems worth it, because if I add 2 numbers and then add 2 of the same number, then divide by 2, I just get that number back. Yeah, so that's number 9. All right. So number 10 is averages again. So this time you're given that you're given the numbers for the first 4 tests in a 6-test course, and you're asked what average score on the last 2 tests would give you an 82%. So the test scores, test scores are as follows: 78%, 92%, 60%, whoops, and 85%. And then two that we just don't know what they are. There's some percent, but we don't know what they are. Well, what we do know is we want the average to be greater than or equal to 82%, right? So let's set that up. What does that look like? Maybe I'll call this, maybe instead of using question marks here, I'll use, I'll call it test 5, and I'll call this one test 6. So T for test, there we go. All right, so if I wanted to do the average of all the scores, that would just be 78, drop in the percents, so we'll have to add those in again at the end. 78 plus 92, oops, plus a 60 plus 85 plus T5 plus T6. Now the trick here, and all over 6 total entries, the trick here is realizing that this right here, adding this part, is the same thing as adding the average of those 2 scores twice. So I'm going to name something new. I'm going to call it the average of 5 and 6. And I can add that twice in place of those 2 test scores. And essentially what we're saying there is that the average of those 2 test scores counts the exact same as in the average as adding the individual test scores. So we can rewrite our average as the average of 5 and 6 2 of those, excuse me, plus, oops, 2 times the 2 of those, plus 78, plus 92, plus 60, plus 85. Divide that all by 6. And we need that to be greater than or equal to 82%. So, well, the thing here is that if we have equal to, then anything greater than that over here will give us greater than. So I can kind of swap this out for an equals sign, solve that problem, and then say, well, any average greater will also work. Okay, so first step is multiply by 6. So I'm just going to rewrite, keep the computations for later. I'm going to put these in parentheses. No real good reason, just easier for me to think of them as one thing. 5. And that's going to be equal. So I'm multiplying both sides by 6. So I get that 6 times 80, 82. 82. All right, and then we see that 2 times the average of 5 and 6 together is equal to 6 times 82 minus all those other numbers. 78 plus 90. Ooh, a little error there. That should be 92. 92 plus a 60 plus an 85. All right, and if we do that out, we come out to 177. So we have 2 of the average of 5 and 6 is equal to 177. Well, then one of those is going to be 177 over 2, and that gets us an 88.5%. So that is the average you have to do on the first and, or the 5th and 6th tests, excuse me. Alrighty, so that's the chapter 1, section 1 stuff. We'll move on to Algebra Aerobics 1.2b. Give me a new page here. Paper, please. All right, so for this one, they give you this equation. And they're like, what do you do to this? Well, what I see here is I see that this is my output. This is my input. So I see that y is kind of determined by the value of x. You know, I compute the value of y by knowing what specific value of x goes with that. Okay, so I'm going to write my description of what's going on here in terms of that. So I would say the value of y is determined by squaring value of x, multiplying the four-letter word, guys, by 3, subtracting x, and adding 1. So there's no reason to just not to give yourself a full verbal description of what's going on. So now they give you a couple solutions, potential solutions, and asks you to identify which ones work. Ain't nothing wrong with that. You can test all of those points they gave you and see what happens. But this is one of those problems. So this is part A. Here. This is one of those problems where you should do C and then go back to B. So do C first. All right, and C is just making an input-output table. So here's my X's, here's my X's, here's my Y's, and we had 3, 2, 1, 0, -1, -2, -3. All right, and I did this in my TI-83 calculator. If you put this into Desmos, which we'll go over a little bit next week, you can also get these values by clicking on the points. I do not intend for the computations to be tedious. So if there's a quick way that you can get all these computations at once, more power to you. I'll be happy to show you a couple ways to do that. Okay, so we're just going to fill these out. We got a 25, and 11, and a 3, and a 1, and a 5, and a 15, and a 31. And so filling out this table, we can see that the only given one that works, I believe, is the 0, 1 option. So yeah, there's your answer to part B. Just by doing C, we found the answer to part B. So B is that 0, 1 works. And that's about all you need to say about that. All right, so that's Algebra Aerobics 1.2b, number 1. Moving on to the Algebra Aerobics 1.3 problem. There we go. So again, abbreviating Algebra Aerobics AA 1.3, number 1. So I'm not going to belabor this one. Give you a couple tables and ask you to identify which one could be a function. So A, check, that's a function. And the reason I said that was that each input is used once. Yeah. And then for B, that is not 1. And that's because 2 goes to 2 places. It goes to 7 and it goes to 8. So that means when your graph is set up, if this is 2, and here's 7 and 8, I got 2 dots. And so if I do the vertical line test here, you can see that I fail. I'm hitting 2 points when I draw a vertical line instead of just one. That's no bueno. All right. So that's all I really want to say about that one. Let's see. So now we went on to the exercises. So I'll abbreviate those EX, then the chapter and section, and then I'll either write a number 3, or again, I'll do something like this, 3.3. Okay, I'm going to do A and C of these, and I think from there you can see what's going on, why B and D are the way they are. For the record, B can be a function and D cannot. So I'll do A and C, and then you can see how they relate to B and D. Okay, so you're given points for these, I believe. I go immediately to an input-output table with these. So for part A, we're given the points 4, 6, 2, 6, 1, -3, and -4, -3. Okay, so yeah, we'll just go straight on to an input-output table. So I'm going to plot these numbers here and these numbers here. 4, 6, 2, 6, 1, -3, -4, -3. And so from here we can see that each input goes to one output. Outputs go to several inputs, but that's okay. It's just about the inputs going to one output that we care about. And also, if we plotted this, what we would find is that we'll put 6 up here, so -3 is right there. 4, -4, there's 2, and there's 1. So if I plot these up, what I get is a picture like this. And so if I go vertical line testing, so we already know this works, right? It does not violate the definition of a function. But if I wanted to do the vertical line test, I can do some drop lines here and see that I'm not hitting another point when I do these vertical lines at the points that I have. So therefore, we have a function. All right, so I will do this another page here and do C. So this is, oops, change color back. All right. So this is exercises from chapter 1, section 3, third exercise, and we're going to do part C here. Okay, so I'll just go straight to the input-output table. Output, we got 2, 2, -2, -2. So as I mentioned in class the other day, as soon as you see that, you know it's not going to be a function because we have repeated inputs, which means that there'd be no reason for that unless we had 2 different output values over here, right? So that's 3, -3, 3, -3. And if we plot this, you can see right away that this is bad in terms of the vertical line test. So I'll do, I will draw a straight line one day. Make this one a little bit bigger. Put that up here. So here's 3, here's -3, here's -2, and here's 2. And yeah, you just got point here, point here, point here, point here. So clearly we see how the vertical line test relates to why that table showed that this was a bad function, or not a function. Yeah, we're failing the vertical line test at those 2 points. There we go. That's section 3. So that was the homework that was assigned Tuesday and the homework that was assigned Wednesday. I'll get to the stuff that was that is listed under Thursday that's due Monday. I'll get that in my next video once I'm better at these. I hope everybody had an easy time seeing that. Any questions, please email me or come by office hours. Hope you guys had a good weekend.